3.
This is lesson 78, force vectors at a point. You guys have already added vectors, right? Now, we're no longer on the coordinate graph, right? We're not. We have two ropes pulling in opposite directions. And you just assume that where the force is, the middle of the pulley, is the resultant force, and it is 0, 0. That's effectively what you're going to do. But now, as they're pulling in opposing directions, what we've been getting, we haven't told you what that's called. That's called the resultant force. Okay? So if I added 4 at 110 and subtracted 5 at 130, and I found that the resultant force was 8.3 at 125. That's what we've gotten sometimes, right? We've had to convert these polar coordinates to rectangular coordinates, add them, and then we get our resultant force. Okay, so we're adding new terminology here, is basically what this lesson is doing, okay? And we're no longer on the coordinate graph system. All right, so look at 78.1 on page 324. All right, it says, 2 ropes are attached to a point and pulled on with the directions and magnitudes as shown. What is the resultant force? Add them. That's what it's telling you to do. Okay? So, we have this pulley. And this angle is 45 degrees. That's the direction. The magnitude is 70. Assume this is your x-axis, okay? Although it's not there, right? This angle is 30 degrees, and the magnitude is 40. All right, you're going to make your right triangles. All right, this is the same thing if I wrote it in polar form as 70 at what? You'd have to go all the way around, right? Right? Okay, you have to consider that. All right, and then this one is your 30 degrees. All right, so what do we need to use? Sine and cosine, right? All right, so we'll start with the cosine. Here is my R, and here is my U. My R is going to be negative in this direction. My R will be positive here. Both of my U's will be positive. Right? Okay? All right, so we do the cosine of 45 degrees equals what? What's my ratio for cosine? Adjacent, which is R, over hypotenuse, which is 70. Multiply both sides by 70. What's 70 times the cosine of 45?
35.
Okay, do S to D.
49.49.
Okay, 49.49. All right, everybody got that? Now let's figure out what my U is. That's the sine of 45 degrees is going to equal U over 70. Multiplying both sides by 70, what's my U? Because it's 45, 45, exactly. Good thinking, 49.49. All right, so for this vector, it's negative 49.49R plus 49.49U. All right? Now I'm going to convert this one to rectangular coordinates, and the same method, right? I do the cosine, but now it's 30 degrees equals R over 40, multiplying by 40 on both sides. What's the cosine of 30 times 40? 34.64. R is 34.64. Okay, now we use the sign to calculate my U. Everyone following? Yes? Okay. What is my U for this vector? Exactly 20? Everyone get 20? All right, 20. So for this one, I have positive 34.64R plus 20U. All right, and then I'm going to combine them. 34.64R plus 20U. All right, what is my R going to be when we combine them? Negative what? 14.85R plus 69.49U. This is the resultant force. Now what if we wanted to convert that to polar? Could I do that? Yeah. I could. All right. Let's do that.
Would you always convert polar?
Typically you do. Okay, but realizing that here's my pulley, right? This is the very middle of it. Okay, I've got my ropes going in both directions. I should fall somewhere in between here and it should go higher, right? The magnitude is typically greater. The direction is somewhere in between here. Okay, so I'm going negative 14.85R, makes sense? I'm going up 69.49U. And this is where my vector is going to be. Got it? That's going to be my direction. Here's my R. So I calculate my R, which is my magnitude, using the Pythagorean theorem. Ignoring signs, 69.49 squared plus 14.85 squared is going to be R squared. All right, let's do that in our calculator. 69.49 squared is 4828.86. 14.85 squared is 220.52, and that's R squared. I'm going to add those together. 4828.86 plus 220.52 gives me 5049. Are y'all checking me?
Yes, sir.
Equals R squared. I'm not done, right? I have to take the square root. And that will give me
71.06.
There we go. 71.06. Now it's R, really it's a lowercase r. R at theta. So now I know my R is 71.06. Now I need my angle. See how it's further than your magnitude, than your longest magnitude. Typically that is the truth. So this is where you should engage your logic, right? If your magnitude and the resultant force ends up less, then question it, okay? Typically, it's always going to be longer. All right, so I'm going to solve for this angle by using the tangent, the arctan. So the tangent of that and it's opposite over adjacent, right? SOHCAHTOA. The opposite is 69.49. The adjacent is 14.85. I'm solving for the angle, so I'm looking for tan to the -1. Shift tan. 69.49 over 14.85. What'd you say? 77.94. All right. And you want to go always from your positive x-axis, which is imaginary here, right, to here. So if this were 180, I would take 180 minus that. And I get, this is 102.06. So it would be 71.06 at 102.06 degrees. Does this make sense? We now have an imaginary axis, okay? Got it?
So what are you doing that's different?
It's no longer on a coordinate graph. And we've added the terminology. This is the resultant force. It's the net of these two forces, okay? All right.
So it's